friends, welcome back to a new video. Today I'll be reading to you another science book. It's called Super Science Infographics series. Let me read you the introduction. Trying to breeze through climate facts just might cause a brain freeze. You're showered with details about extreme temperatures and more. So let's get straight into this book. Weather and climate through infographics. The wonders of weather and climate. Do you have a future that includes all things weather and climate? To find out, take this test. 1. Do you want to know what causes the seasons? Do you enjoy discovering record temperatures? Are you curious about clouds? Do you have extreme interest in extreme weathers? Did you answer yes to any of those questions? Congratulations. You've got the right stuff to explore the wonders of meteorology and climatology.
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 Okay. Earth's weather and climates are complex and diverse. They involve the sun, Earth's location and rotation, the sky, and water. Meteorologists and climatologists use graphs, charts, and other infographics to help sort through all the information. These same tools can help you understand what makes our planet a cool place and a hot one too. The forecast looks good for learning. So read on to learn more about the interesting and sometimes dangerous features of weather and climate. Same difference. Weather versus climate. Weather and climate are similar, but not the same. Weather is what's going on in Earth, in Earth's atmosphere at a particular place during a brief period of time, such as a day, a week, or a season. You know temperature, cloudiness, precipitation, and wind. Climate is weather over a much longer period, usually 30 years. It lets you know what weather is usually like in a place. The planet has lots of climates. The categories are based on the temperature, precipitation, and vegetation. Climate key. Type A, tropical humid. So that's tropical humid. Very warm all year long. And a lot of rain. The monthly average temperature throughout the year is 64 Fahrenheit. That is 18 Celsius. Type B, dry. Very little precipitation. The ground can lose moisture because so little comes from the sky. Type C, moist with mild winters. Warm summers, mild winters. The average temperature for the coldest month is 27 to 64 Fahrenheit, minus 3 Celsius to 18 degrees Celsius. Type D, moist with cold winters. Warm summers, cold winters. The average temperature of the warmest month is above 50 Fahrenheit, 10 degrees Celsius. And the coldest month is below 27 Fahrenheit, minus 3 Celsius. Type E, polar. Cold all year long. The average temperature of the warmest month is below 50 Fahrenheit, 10, 10 degrees Celsius. Type H, mountainous climates. Oh, highland. Type H is highland. Mountainous climates affected by altitude. They can range from tropical to frigid. Frigid. Here comes the sun. The sun releases lots and lots of energy. Very little of it reaches the earth, but enough gets here to light and heat the planet. The energy also causes the weather and affects climate. Millions of miles in minutes. The sun's the sun's heat travels 93 miles, 150 million kilometers, to Earth in approximately 8 minutes. Bring on the sun. The sun shines on every place on Earth, at least the part of the year. Seri- Serious sun power. Imagine us Imagine a bridge made of ice. That's 2 miles, 3.2 kilometers wide. One one 1 mile, 1.6 kilometer thick, and reaches all the way from Earth to the sun. The sun releases so much energy it would melt that bridge in 1 second. Oh my goodness. Um Not all the sun's energy that reaches Earth actually makes it to the planet's surface. 8% bounces off air, 6% reflected by the surface, 4% absorbed by the clouds, 46% absorbed by land and sea, 17% reflected by clouds, 19% absorbed by water vapor, dust, and ozone. And if you don't know what ozone is, it's a layer that protects Earth from the sun's heat. If we didn't have that, then we would be in ashes. Angle of incidence. The sun's energy hits Earth with different intensities because the planet is round. Sunlight is most concentrated at the equator, where it hits the planet directly, moving toward the poles. Sunlight. Oh my goodness. Sunlight covers more area but is less concentrated. This difference in heating affects the climate and weather. The, the, angle, the angle formed where sunlight hits the planet's surface in the angle of incidence. The scoop on the seasons. Some climates have distant seasons that are very different from one another. Others don't. The equator is pretty much the same all year long, varying only in the amount of rain. The farther you move from the equator, the more difference you'll see in the seasons. This of variety is a result of the sun and Earth's orientation to it. Earth spins in an axis at the angle and orbits the sun. As the planet moves around the sun, the quantity of sunlight reaching different parts of Earth varies. The amount of variance through the year differs across the globe. June 20 or 21. First day of summer in the northern hemisphere and winter in the southern hemisphere. The sun is the farthest north from the equator. There are 24 of light at the Arctic Circle. Earth moves clockwise around the sun. September 22 or 23. First day of fall in the northern hemisphere and spring in the southern hemisphere. The first day of spring and fall are the
Equinox.
equinox. Day and night are the same length on these days. December 21 or 22. First day of winter in the northern hemisphere and the spring in the southern hemisphere. The sun is the farthest south from the equator. There are 24 hours of darkness at the Arctic Circle. Uh, Earth circles the sun, but its orbit isn't actually a circle. It's an
Ellipse.
ellipse, which means shaped like an oval. Um, March 20 or 21. First day of spring in the northern hemisphere and fall in the southern hemisphere. Earth rotates clockwise. Red hot, ice cold. Do you like extremes? Earth experiences temperatures from hot, hot, hot to super duper cold, and everything in between. Some it's raining. Some climates tend to be hot or cold. Others have combinations of temperatures varying from warm summers to frigid winters. And sometimes extremes occur within unbelievably short period of time, with temperatures changing dr- drastically in a matter of hours rather than across months. Approximately minus 150 Fahrenheit or minus 101 degrees Celsius. Coldest estimated wind chill ever recorded, a remote weather station in Antarctica. July 4, 2003. Temperature scales. The United States uses the Fahrenheit scale. Most other countries use the Celsius scale, which is also used called centigrade. Need to convert a temperature? Here's how. Fahrenheit to Celsius. F minus 32 times, what is that? I can't even see that. 5 to 9, I guess. Centigrade, Celsius to Fahrenheit. Celsius times 9 by 5, I guess, plus 32. I don't get that. World record change. Loma, Montana set a world record in 1972 with the biggest temperature change in a 24-hour period. From January 14 to 15, the temperature went from minus 54 Fahrenheit to 49 degree Fahrenheit. So that is 48 uh, degree degrees Celsius to 9 degrees Celsius. And that is 103 degrees. Extreme heat in Australia. In January 2003, temperatures in Australia were so high that the National Meteorology Bureau added two colors to its weather chart: dark purple and violet, representing temperatures ranging from 100 and 124 degree Fahrenheit to 129 degree Fahrenheit. That is 51 degrees Celsius to 54 degrees Celsius. Hottest 134 degree Fahrenheit, 57 degrees Celsius. Hottest temperature on Cold Death Valley, California, July 10, 1913. Uh, 155 degree Fahrenheit to 160 degree Fahrenheit, 68 degree Celsius to 71 degrees Celsius. Hottest heat index ever recorded: Dirhan, Saudi Arabia, July 8, 2003. Minus. I'm sorry, I skipped this one, so I'm reading it now. Minus 29 degree Fahrenheit and that is minus 89 degrees Celsius. Coldest temperature on record Vostok, Antarctica, July 21, 1983. Up above the world so high. Do you ever look up to the sky and wonder about it? There's a lot going up. There's a lot going up there. What we usually call the sky is the atmosphere. It's a thin layer of air that surrounds the planet and acts like a protective bubble. The Earth's atmosphere is the most complex in the Milky Way. It provides the air we breathe, holds moisture, keeps in heat, and blocks damaging sunlight. The atmosphere extends for thousands of miles and gets thinner as you go further away from the planet. Our chilly moon, Earth's average surface temperature is 59 degree Fahrenheit, and that is 15 degrees Celsius. The moon uh, is 0 degree Fahrenheit, and that is minus 18 minus 18 minus 18 Celsius. The moon, unlike Earth, doesn't have an atmosphere to trap heat. Atmosphere 375 to 6,200 miles, 604 to 10,000 kilometers high. Atoms and molecules here escape into space. Thermosphere 59 to 375 miles, 90 to 604 kilometers high. This layer uh, this layer can reach temperatures up to 3,600 degree Fahrenheit. That is 2,000 degrees Celsius. Mesosphere 31 to 56 miles, 50 to 90 kilometers high. The coldest parts of the atmosphere are here, as low as minus 18 degree Fahrenheit, and that is minus 20 degrees Celsius. Stratosphere 21 to 31 miles, 20 to 50 kilometers high. The ozone the The ozone is here. It soaks up the sun's ultraviolet rays, which are harmful. Um, Troposphere. Earth's surface to 4 to 12 uh, Earth's surface to 4 to 12 miles, 6 to 20 kilometers high. The air gets thinner at the airs get thinner the farther you go from Earth. So you start off here. These are like all the air molecules because the air molecules are jammed together. So you keep going further and further, and this is how it eventually gets. 10 steps to watering the earth. Jumping in puddles in the rain can be fun. So can catching snowflakes on your tongue. These activities are made possible by mm, precipitation. Mm, water. More than half of Earth is covered in water, approximately 70%. That includes all forms liquid, ice, and vapor. Most of it is in oceans. Water constantly moves through uh, Earth's Earth, Earth and atmosphere through the water cycle. Um, Precipitation comes in many forms. The type is determined by temperature and size. Earth is the only known planet where water exists as a liquid, a solid, and gas. Rain 0.02 plus inches, 0.5 plus millimeters. Drizzle drizzle less than 0.02 inches. Freezing rain. Hail 0.2 inches or more. Sleet 0.2 inches or less. Snow. Evaporation. The sun's heat changes water from liquid to vapor. It moves from Earth's surface to the air, and there's all the steps they're showing you in pictures. I'll keep on reading, and you guys can look at the pictures. Transpir- Transpiration. Water evaporates from trees and plants. 3. Simulation. Ice and snow becomes water vapor skipping and liquid phase. 4. Condensation. Water vapor changes back into liquid cloud form. 5. Transportation. Water moves in all states. This moves water from over the oceans to over land. Precipitation. Water that falls to the earth. It occurs mostly as rain but includes snow. Runoff. How water travels over earth. It comes from rain and snow. Infiltration. Water moves from the surface on into the ground. Groundwater flow. Water moves underground. Plant uptake. Water moves from underwater into soil where plant and tree roots can get it. And now you can just take a look at all the pictures, run through the steps again, and maybe see like maybe read the side stuff. And I'm just gonna read this part now. You can pause the video if you'd like. And I'll just give you a second to just look back and try to understand the picture and absorb the information in. Okay, I hope you've done it now. I'll read this water drop. Rain is the must weird font. Oh, rain is the most common form of precipitation. I'm gonna give you another second to just look again because you really gotta look at this picture to understand it. Okay. Thick, thin, puffy, wispy. Okay. Now stretching out on the ground and looking up at the clouds for familiar shapes can be lots of fun. Clouds can be wispy and barely there, or thick and fluffy. Sometimes they stretch high into the atmosphere or blanket the sky. Clouds form when so much moisture in the air when so much moisture in the air that is vapor becomes droplets or ice crystals. This happens when rising moist air is cooled enough to cause condensation or the amount of water in the air has increased, such as through evaporation. Check out different cloud types and their shapes. Fog, a cloud at Earth's surface. Status, forms at low levels and often covers the entire sky. Stratus, stratus is Latin for layer. Nimbus, that's strange. Nimbus is like the app I use. Nimbus. Develops between 7,000 and 15,000 feet, 2,100 and 4,600 meters. Nimbus is Latin for rain. Cumulus can stretch 1,000 of feet high. Cumulus is Latin for heap. Circa, cirrus, formed above 2,000 feet, 60,000 meters. Mostly ice crystals. Cirrus, mostly ice crystals. Cirrus is Latin for curl. I can't read that because I'm using a Chromebook and Opera. Let me try my best actually. Stratocumulus. Status nimbostratus. Low clouds 0 to 6,500. Accumulus. Accumulus. And allostratus. Middle cloud to 6,500 to 20,000 feet, 1,981 to 6,096 meters. Cirrus above 20,000 feet. Cumulus cirrus high cloud 16,500 to 42,500 feet, 5,029 to 12,954 meters. Cirrus, Nimbus, Cumulus, Stratus. Meteorologists categorize clouds by their height in the atmosphere and how they appear from below. These funny sounding words are categorized of clouds. Blow, windy, blow. Blow, wind, blow. Ever wonder where wind comes from? ever wonder where wind comes from? It's air in motion. Heat differences cause air to move. Earth's atmosphere in is in constant motion as warm air at the equator heads to the poles, and cold air at the poles moves back to the equator. These shifts create global patterns of circulation and powerful jet streams high in the atmosphere. Even winds capable of great destruction at Earth's surface. The, do- the, dol- the doldrums. The area around the equator is often called the doldrums. Calm winds, calm winds here make it difficult for weather. Um, Trade winds. Warm, steady breezes that blow westward and toward the equator. West, westerlies. Wind between 30-degree and 60-degree latitudes that blow from the west and toward the poles. Wind above 60-degree latitude that blows over the poles from the east. Jet streams. Each hemisphere often has two jet streams and sometimes three. Winds winds here winds here blow at high speeds from west to east in long narrow areas. Jet streams circle Earth in winding paths that change with the season. They're closer to the equator and move faster in winter than in summer. Some jet streams can cause storms. Others occur with nice weather. Um, 80, 80 miles per hour at 129 kilometers per hour. 100 miles per hour, 161 kilometers per hour. 120 miles per hour, 193 kilometers per hour. 140 miles per hour and 225 kilometers per hour. Subtropical jet, and that's the polar jet. And that is the equator, the line that goes in the middle. Round and round it goes. Earth's ocean water is like its atmosphere, constantly on the go, circling the globe. Ocean water moves heat from the equator to the poles, at the surface and deep underwater. O- Ocean currents move water at the surface, and the thermohaline circulation moves water far below the surface. The deep currents are slower than the surface currents. Changes in the ocean temperature can cause major weather events, such as hurricanes and droughts. Warm water surface current, cold water surface current, warm water deep current, cold water deep current. Ocean affects temperature. Land near water is more temperate than land. Uh, that's be, mm, Water is more temperate than land far from water. That's because water changes temperature slowly. Coastal cities are warmed and cooled by winds blowing from the ocean. Winds that blow inland don't come directly from the ocean. Compare Seattle, Washington, Bemidji, Minnesota. Their They're almost the same distance from the equator, but they have difficult climates. Winds blowing in from the ocean keep settle relatively cool in summer and warm in winter. Bemidji isn't near an ocean. Its summer and winter temperatures are more extreme. A settled latitude is 47.4. Um, I don't even know what that is. And I'm good, I guess. Um, average average January low 30, 36 degrees Fahrenheit and 2 degrees Celsius. Average July high 75 degrees Fahrenheit and 24 degrees Celsius. Bemidji, Mem, Bemidji, Bemidji, Bemidji latitude is 47.3 N. Average January low minus 4 degree Fahrenheit, minus 20 degrees Celsius. Average July high 79 degree Fahrenheit, 29 degrees Celsius. Front and center. Air 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 masses are major players in weather because of their size and their effects. An air mass is a big body with air with similar temperatures and moisture. An air mass can stretch for miles. Air masses form when air sits over an area an area long enough to match the area's temperature and moisture. Air masses have boundaries called fronts. A warm air mass is led by a warm front. A cold air mass has a cold front. Fronts often cause changes in wind, humidity, cloudiness, and precipitation. While the different types of masses and fronts move differently, one thing is similar about them: the weather. What's going to change? Fronts are on a weather map: cold front and warm front. Sorry. Cold. Types of front. Cold. Fast moving cold air runs into slow moving warm air. Expect strong winds and thunderstorms. Cold fronts usually move faster than warm fronts. Slow moving warm air runs into slow moving cold air. Expect clouds and possibly rain or fog. Warm. Almost done. Going extreme. Every year, people around the globe experience severe weather disasters. A single event can cause hundreds or even thousands of people to die or become homeless. Cleaning up and repairing what's left after an event can cost millions and millions of dollars, and recovery can take years. 1972 Iran blizzard. Iran, February. About 4,000 people died. Blizzard, a severe winter storm with winds at least 35 miles per hour, 56 kilometers per hour, for 3 hours and visibility limited to 0.25 miles, 0.4 kilometers. 1989, Saturia Manikanyu Sadr tornado. Majalkin district, Bangladesh, April 26th. About 1,300 people died and 10 of thousand were left homeless. It is believed to be the deadliest tornado recorded in history. Tornado, usually associated with thunderstorms, this is a destructive column of air that rotates and touches the ground and can have wind speeds as high as 300 miles per hour and 483 kilometers per hour. 1995 Mayfest storm. Torrent and Dallas Counties, Texas. May 5. 20 people died, dozens were injured, and damages were estimated at about 2 billion. Thunderstorms. A violent storm with lightning, thunder, heavy rain, winds at least 58 miles per hour, 93 kilometers per hour, and hail with diameter of at least 0.75 in 2 centimeters. 1999 Venezuela floods. Sarcas, Venezuela, December. 2 weeks of heavy rain caused flooding and landslides. It is estimated that 10,000 to 30,000 people were killed and tens of thousands were made homeless. Floods and flash floods. An overflowing of a river, sometimes seasonally, sometimes seasonally, sometimes because of storm surge. Flash floods occur suddenly within 6 hours of heavy rain and can take over streets. 2003 European heat wave. Europe, June to mid-August. At least 30,000 people died. The heat wave melted glaciers, contributed to rock slides and forest fires, and affected harvests. Drought. A lack of rain for a long period that leads to water shortages, damages crops, reduces flow of streams, and dries the ground. Hurricane Katrina. Gulf Coast of the United States, August. Almost 2,000 people were killed. Katrina, the most expensive hurricane in the US, caused 80 billion in damage. Hurricane, a strong circular storm that starts over warm tropical oceans with winds at least 74 miles per hour, 119 kilometers per hour, and lots of rain. It causes huge storm surge, making sea levels reach higher than usual. As much as 20 feet, 6 meters, hurricanes are usually 200 miles, 320 kilometers across. They are also known as cyclones, tropical cyclones, and typhoons. From outside to you. Weather information is in high demand. The National Weather Service (NWS) gathers weather data from high and low and feeds it into supercomputers that turn it into forecasts. These weather predictions go to all kinds of organizations and often shape predictions published in all kinds of places. Entire televisions and cable stations are devoted to weather. Here's the process. It's as easy as 1, 2, 3. Weather watchers. The NWS almost 290,000 volunteers trained to spot severe weather in free classes. Spotters learn about identifying and reporting severe weather, as well as severe weather safety. Step 1. Gather data. Meteorologists gather information from a variety of sources to create the most accurate forecast possible. The information includes the measurements of things such as temperature, wind direction, wind speed, humidity, and liquid prediction like rain or snow. Step 2. Process data. Supercomputers process weather observations to make predictions. The National Weather Service runs these computers in the United States. Step 3. Create and distribute forecasts. The NWS has a variety of officers and centers that distribute forecasts and warnings. Other groups and people create and share forecasts, including private forecasting companies and television meteorologists. The military has forecasters too. That's it. Okay. So guys, this is the end of the book. If you enjoyed, then please like, share, and subscribe. For this series, we have read Forces in Motion. This one. This is the book we read, and we just finished this book right over here. So we got these two books. This one, and we got this one. And there's like solar system through infographics, life science to infographic, national disasters to infographic, energy and waste to infographics. So there's all these 4 books left. 6 books left. No. Okay, I was just joking. Oh, and I know what to do. Huh. But that doesn't fit. Here. So there's 6 there are 5 more books left. Okay, fine. There are 4 more books left for us to read, and I'll be reading them all in other videos. And I have also posted a new video. It's like how to draw a cat on Google Slides. Like, for example, you could use it for like if you need to make a slide presentation, you can make characters on it. I'll be posting a new video on how to draw a cartoon character or human on Google Slides, because I showed only a cat, but now I want to show how to draw a human. It'll be a whole series, so yeah. And that's it for today. I hope you enjoyed, and I'll see you next time. Goodbye.